Hello, in this video we're going to look at activity 22 in the BrightSparks 4kids guide. Now in activity 21 we looked at our thermistor and investigated its resistance using a multimeter. In this activity we're going to create a circuit in which to test its resistance and see how it affects the operation of another component in the circuit. We're going to make a series circuit and we're going to use 4 cell and cell holders . As we've done before, we're going to wire these in series and we're going to start that now. So I'm going to put a black lead in the negative terminal of the first cell. We have a red lead to go into the red positive terminal of our first cell, and that is going to go into the black negative terminal of our second cell. Put another lead into the red positive terminal of our second cell, connect it into the black negative terminal of our third cell. And then connect this lead into the red positive terminal of the third cell and connect it to the black negative of the fourth cell. And then we'll put a lead into the red positive cell on this fourth cell. So now we have a circuit ready to incorporate our components. So first of all, we're going to connect our thermistor. So using the lead from the black negative terminal to our thermistor and plug in another lead. Now the next component in our circuit is going to be a red flashing LED. So here we have our flashing LED or flashing light emitting diode. And here you can see the circuit symbol. We have a black negative terminal and a red positive terminal. So it's very important that we wire this in correctly, otherwise our LED, our flashing LED, won't work. So if I connect our black lead to our negative terminal and our red lead to our positive terminal, you might just be able to see we've got a very dim flashing LED. If I put my finger on it, we found that if we increase the heat on our thermistor, then that should reduce the resistance. And if we reduce the resistance, then our flashing LED should grow brighter. Now, my finger's not enough to make a difference, so what I've got a hairdryer, so I'm going to use a hairdryer hopefully you can see that our LED is flashing much brighter. Now, as our thermistor cools down, gradually the resistance is going to increase and our LDR, our flashing LED, will gradually become dimmer and dimmer. So I can already see that this is beginning to happen, and what we could do is we can use a frozen sample. So I've taken an ice pack from the freezer, and now what I'm going to do, I'm going to place that on the thermistor here. And you should be able to see that now the LED is getting dimmer and dimmer. And that is because the ambient temperature is decreasing on our LED, and so the resistance in our circuit is increasing. You can see now that we can just about make out that our LED is flashing. And if I keep this frozen pack, this freezer pack, on our component, it'll grow even further dimmer, so we will just about be able to tell that it's operating. Perhaps what you could do in that investigation is time how long it takes for you to not be able to see the flashing LED work. But with our circuit and using our hairdryer and our ice pack, we've been able to show and demonstrate the characteristic, the operating characteristic of our thermistor component. There you go, you can barely see it working. In fact, the resistance is now so great that our flashing LED isn't operating anymore.